Every good database schema starts life as boxes and lines on a whiteboard, long before anyone writes a single line of SQL. Those boxes and lines have a name, an entity relationship diagram, or ERD. And once you can read one, you can design a database like an engineer instead of guessing at tables. In the next few minutes I'll teach you the whole language of ERDS. The rectangles are your entities, the things you store. The attributes listed inside them are your columns, with the primary key marked. The lines between the boxes are your relationships, the verbs. A customer places an order contains products. Then the part almost everyone gets wrong, cardinality, drawn with crow's foot notation, those little bars, circles, and three-pronged crow's feet on the ends of each line that tell you one, many, or optional. We'll take a tricky many-to-many relationship and resolve it the right way. And finally we'll turn a finished diagram straight into real create table statements, because every box, every attribute, and every line maps to exactly one piece of SQL. This is not a video about normal forms, a companion video covers those. This is about reading and drawing the diagram itself. Let's draw. Let's start with entities and attributes. An entity is simply a thing you need to store, a noun in your problem. A customer. An order. A product. On the diagram, each entity is a rectangle, and each rectangle becomes exactly one table in your database. Inside the rectangle you list its attributes, the facts you keep about that thing. For a customer, that's an ID, a name, and an email. Those attributes become the columns of the table. One attribute in every entity is special, the primary key, the attribute that uniquely identifies each row. Customer ID. Order ID. On an ERD you mark the primary key by underlining it, or by tagging it PK. It is the handle that everything else will grab onto. Most entities are strong entities, they stand on their own, identified by their own key. Occasionally you meet a weak entity, one that cannot exist without a parent and is only partly identified by it. An order line has no meaning without its order. Don't overthink weak entities, just know the term exists. The headline to burn in, entity equals rectangle equals table. Attribute equals column. Underline the primary key. Get that, and you have already drawn half of every diagram you'll ever make. Now let's connect the boxes. A relationship is a verb that links two entities, drawn as a line between their rectangles. A customer places an order. An order contains a product. A student enrolls in a course. Always read the verb in both directions to sanity check it. A customer places orders, and an order is placed by a customer. Good, that holds. In the classic chain notation, the relationship is drawn as a little diamond sitting on the line with the verb written inside it. Modern tools, and this video, just write the verb along the line itself and leave the diamond in the textbooks. Either way, the line says these two things are connected. What the plain line does not yet tell you is how many, is a customer connected to one order, or to 1,000. That number is called the cardinality, and it is the single most important piece of information on the whole diagram. It's carried by the little symbols drawn on the ends of the line. That's what we cover next, and it's exactly where crow's foot notation earns its name. Cardinality means how many instances of one entity relate to the other, and we draw it with crow's foot notation, the symbols sitting on each end of the line. There are three basic marks. A single bar across the line means 1. A little circle, or ring, means 0, in other words, optional. And the three-pronged mark that looks like a bird's footprint, the crow's foot, means many. Now the clever part, each end of the line carries two of these symbols, and together they read as a minimum and a maximum. The symbol nearest the entity, the outer one, is the maximum, a bar for at most 1, a crow's foot for many. The symbol just behind it, the inner one, is the minimum, a bar for at least 1, meaning mandatory, or a circle for 0, meaning optional. So a bar with a bar means exactly 1. A circle with a bar means 0 or 1. A bar with a crow's foot means 1 or more. And a circle with a crow's foot means 0 or more. Let's read our real example. A customer has 0 or many orders. A brand new customer might have placed none yet. So on the order's end of the line we draw a circle and a crow's foot. And each order belongs to exactly 1 customer, never 0, never 2. So on the customer end we draw 2 bars, exactly 1. Here's the rule for reading any diagram: look at the marker nearest an entity to answer how many of this thing take part. Bar on the one side, crow's foot on the many side, that is a one-to-many, and it is the most common relationship you will ever draw. Some relationships are many-to-many. A student can enroll in many courses, and a single course holds many students. Try to draw that with just the 2 boxes and you hit a wall. There is nowhere to put a foreign key, because neither side has one single partner to point at. A relational database simply cannot store a many-to-many relationship directly. The fix is to resolve it on the diagram. You introduce a new box in the middle, an associative entity, also called a junction entity or a linking entity. We'll call ours enrollment. Enrollment sits between student and course, and it holds 2 foreign keys, a student ID and a course ID, one pointing at each parent. And watch what happens to the crow's feet. The one big many-to-many splits into 2 clean one-to-many relationships. One student has many enrollments, one course has many enrollments, and each single enrollment points at exactly 1 student and exactly 1 course. The junction entity is also the natural home for any facts about the pairing itself: the date the student enrolled, the grade they earned. So the lesson: whenever you see a many-to-many on your whiteboard, resolve it into a junction entity holding 2 foreign keys before you write any SQL. It's the same idea as a junction table, just framed as fixing the diagram. Here's the payoff: turning the finished diagram into real tables. The mapping is completely mechanical, and that's the whole reason we draw first. Rule 1: each entity becomes a create table. Rule 2: each attribute becomes a column, and you give it a type. ID becomes an integer, name and email become varchar or text, a date becomes a date. Rule 3: the primary key attribute, the one you underlined, becomes primary key. Rule 4: the rule that ties everything together: every one-to-many relationship becomes a foreign key on the many side, referencing the primary key on the one side. Watch the customer to orders example. Customers becomes a table with ID as its primary key. Orders becomes a table with its own ID, and because an order belongs to exactly 1 customer, orders carries a customer ID column declared as a foreign key that references customer's ID. The crow's foot end, the many side, orders, is always the side that holds the foreign key. Do the exact same thing for the junction. Enrollment gets a student ID and a course ID, each one a foreign key to its parent, and together those 2 can even serve as its primary key. Boxes become tables, attributes become columns, lines become foreign keys. The diagram is a blueprint you read straight into SQL. You don't have to draw these by hand forever, though doing a few by hand really is the fastest way to learn the notation. A great free option is diagram.io, where you type a few simple lines of text and it renders the boxes, the lines, and the crow's feet for you, and then exports the SQL. If you live in Markdown, Mermaid has an erdiagram block that turns a handful of lines of text into a rendered diagram right inside your docs or your GitHub README, which is perfect for keeping the diagram next to the code. And plenty of working engineers still start on a literal whiteboard or the back of a napkin. That is completely valid. The diagram is a thinking tool first and a formal document second. Pick whichever one gets the boxes and lines out of your head the fastest. The notation you just learned is the same in every one of them. So that's the entire language of entity relationship diagrams, start to finish. Entities are rectangles, and each one becomes a table. Attributes are the columns listed inside, with the primary key underlined. Relationships are the verbs, the lines drawn between the boxes. Cardinality is the crow's foot notation on those lines, a bar for 1, a circle for 0 or optional, a crow's foot for many. Read the outer symbol for the maximum and the inner symbol for the minimum. A many-to-many always resolves into a junction entity holding two foreign keys. And the finished diagram maps mechanically to SQL, entities become tables, attributes become columns, and every one-to-many becomes a foreign key on the many side. I've put a free, deeper written guide to database design and normalization in the description below, and if you want the complete package there's an optional SQL and database design pack down there too. Draw the boxes before you write the code, your future self will thank you. Subscribe for more deep dives like this, and I'll see you in the next one.